Assalamu alaikum. This is the 7th class of transformation of functions, and today we will be continuing with the past paper questions which we are doing in class 6. Okay, starting with question number 12. The question is, given that f of x equals to x square, sketch the graph of y equals to f of x. Okay, sketching the graph of x square is very simple. You simply have to draw the curve, and the curve of y equals to x square passes through the origin. So, you can just simply draw the curve. The graph of y equals to g of x is obtained by reflecting the graph of y equals to f of x in the x axis. The graph of y equals to h of x is obtained by transferring the graph of y equals to g of x by 2 units parallel to the y axis. Sketch and label the graph of y of g of x equals to y and y of y equals to h of x on a single diagram. Okay. So, if I have to draw g of x and f of x on the same diagram, I will draw the coordinate axis. Okay. G of x is the reflection in the x axis. So, you are going to simply reflect the graph in the x axis. If this is the graph of y equals to x square, this is the graph of y equals to g of x. Okay, and h of x is transferring the graph of g of x by 2 units parallel to the y axis, positive 2 units parallel to the y axis. So, the graph of h of x is going to be this graph. You have to shift it 2 units, translating the graph by 2 units. So, you have to shift the graph 2 units upward. This will be the graph of y equals to h of x. Okay. Write down an expression for y equals to g of x and h of x in terms of x. This is going to be g of x is going to be negative x square, and h of x is going to be negative x square plus 2. Okay. Then we are doing this question number 13. We can see cubic equation, the graph of cubic equation. Graph diagram shows the graph of y equals to x cube. The graph of y equals to x cube is given a translation of 4 units parallel to the x axis. Okay. 4 units parallel to the x axis as shown in the diagram B. The whole graph has shifted 4 units onto the right. Write down the equation of the translating graph. Since you are shifting it on the right, so x minus 4 the whole cube will be the equation. Okay, and then they are saying the graph of y equals to x cube is given a stretch parallel to the x axis. Parallel to the x axis, that means horizontal stretch with scale factor 2, followed by a translation of negative 3 units parallel to the y axis. Okay, as shown in diagram number C. Write down the equation of the transformed graph. Okay, this graph y equals to x cube is given a stretch parallel to the x axis with stretch factor 2. Stretch factor 2, the equation is going to be y equals to, in place of x you will write 1 upon 2 x, because if the stretch factor is 2, what do you write in the bracket is the reciprocal of the stretch factor, which is 1 upon 2 x cube, and then it is supposed to be translated 3 units down. Okay, translation of negative 3 units parallel to the y axis, so negative 3. When you simplify it, you get 1 upon 8 x cube minus 3. This will be the final answer. Okay, moving on to question number 14. The diagram shows the graph of y equals to f of x. The point 2, 1 lies on the curve. Sketch on the separate diagram the following graphs. On each graph, label the image of the point P given its coordinates. Y equals to negative f of x. Negative f of x meaning you just have to reflect the graph in the x axis. Okay, so in order to reflect, I am doing it on the same graph. So, you have to reflect the graph in the x axis. When you reflect the any graph in the x axis, the x coordinate remains the same, but the y coordinate changes the sign. So, this point is going to be 2, negative 1. Okay. Okay, and then in the next graph we are supposed to give it a stretch factor of parallel to the y axis, that means a vertical stretch of 2 units, and then a translation of the vector negative 3 0, that means you have to shift it 3 units onto the left. Okay. So if I draw this graph, first of all, if I give it a stretch factor of 2, that means this point, which is 2 comma 1, is going to go on to 2 comma 2. Okay, this point is also going to shift 1 unit up. Okay, so this is the graph with the stretch factor 2, which I am drawing right now. Okay, after this you are going to simply shift the graph 3 units onto the left. So this point, which is 2 comma 1, 2 comma 2 right now, is going to shift 3 units onto the left. That means 2 comma negative 1 comma 2. So the final graph will be the pink graph which I am drawing. The shape is going to be somewhat the same. This will be the graph. Okay, then they are saying the graph of y equals to 2 f of x plus 3 is obtained from the graph of y equals to f of x by a sequence of 2 geometrical transformation. Describe each of these transformations only fully. Okay, so you will say the first one is okay, since you are giving it you are doing vertical transformation, so it is going to be first of all you are translating it by, even if you write the first one first, that means you give it a vertical transform stretch, a vertical stretch parallel to the y axis with stretch factor 2, and then a translation of by negative 3 comma 0. Okay, or it can be a translation of negative 3 0 and then a stretch of 2 in y direction. It can be either of these two. Either you shift it, if you give it a stretch of 2 parallel to the y axis and then shift it, or you shift it first and then give it a stretch, the final result is going to be the same, because one of them is a horizontal translation, that means you are shifting it horizontally, and one you are shifting it vertically. So if one of them is a horizontal shifting and the other one is vertical, you can change the order and the result is going to be the same. Okay, then we move on to question number 15. The point R 6 comma negative 3 is on the curve y equals to f of x. Find 6 comma, if we just try and locate it, 6 comma negative 3 is going to be this point. Okay, now find the coordinates of the image of R when the curve is transformed by half of f of x. Half, before this meaning it's a stretch, it's a vertical stretch with stretch factor half. That means the point where whatever is the distance from the x axis will be halved. So now this point, which was 6 comma negative 3, is going to go on to 6 comma negative 1.5. So you can write down the point 6 comma negative 3 will go on to 6 comma negative 1.5. So this is the answer for the first part. Okay, then they are saying find the coordinates of the image of R when the curve is transformed to y equals to 3 of f of 3x. Now it's a horizontal stretch and the stretch factor is 1 upon 3, because in case of horizontal stretch, whatever is the number given here, you reciprocate it and that becomes the scale factor of the horizontal stretch. So the original point, which was 6 comma negative 3, is here. If you have to give the horizontal stretch of 1 upon 3, that means whatever is the distance from the y axis, it will be 1/3. Now the distance is 6 from the y axis, so it will go on to 2. So it is going to go on to 2 comma negative 3. This will be the final answer. So 2 comma negative 3 will be the final answer. Going on to question number 16. Figure 8 shows the graph of y equals to g of x. Draw the graph of y equals to g of 2x. G of 2x, once again, is a horizontal stretch and the stretch factor is 1 upon 2. That means you have to see whatever is the distance of every single point from the y axis. Okay, in case of horizontal stretch, we see the distance from the y axis. Whatever is the distance, you have to make it half. Okay, so I'm just marking the points. this point is going to go on to this point. This point which is at 6 is going to come here. Okay. So this point is going to go on to this point is going to go on to this, and this point which is having a distance of 2 units from the y-axis will come on to this point. So the final graph is going to be likewise this point is going to shift here. Okay, so I am just joining these points to get the similar shape. This is the answer. Then in the next part they are saying 3 times g of x, it is a vertical stretch with stretch factor 2, oh 3 sorry. Okay, if the stretch factor is 3, you just have to see whatever is the distance from the x-axis. In case of vertical stretch, we see what is the distance from the x-axis, you make it into 3. So if the distance of the original graph is 1 unit, it has to go on to, the distance will now become 3 times the original distance. So here this point is also going to move here. This point which is having a distance of 2 units from the x-axis is going to go on to 6 now, and this point will remain as it is, because any point which is on the invariant line, in case of vertical stretch, x-axis is the invariant line, so it will remain the same. So it's going to be like this. Okay, I hope it's clear. Then we move on to question number 17. It says the graph of y, the point P 6 comma 3 lies on the curve y equals to f of x. Okay, let's quickly draw it. 6 comma 3 is this point. Okay, state the coordinates of the image of P under the transformation which maps y equals to f of x onto y equals to 3 times f of x. That means it's a vertical stretch with stretch factor 3. Okay, so this point which is having a distance of 3 units from the x-axis, okay, it is going to go on to triple the distance. Now it will go on to 6 comma 9. Okay, so the answer is going to be 6 comma 9. Okay, f of 4x, it's a horizontal stretch, okay, with stretch factor 1 upon 4. Okay, so you have to see whatever is the horizontal distance from the y-axis, it will be 1/4 of the distance. 6 divided by 4 is 3 upon 2 or 1.5. So it's going to go on to 1.5 comma 3. Question number 18. In this equation, f of x equals to x square minus 5x. Figure 4 shows a sketch of the graph of y equals to f of x. On separate diagrams, sketch the graph of y equals to f of 2x and y equals to 3 times f of x. I am doing it on the same diagram, graph of y equals to f of 2x. So we know it's a horizontal stretch, okay, with stretch factor 1 upon 2. That means whatever is the distance, okay, whatever is distance from the y-axis, it will be halved. Okay, so it's 5 here, so this point is going to go on to 2.5 comma 0. This is one x-intercept, the other x-intercept will remain as it is, because in case of horizontal stretch, y-axis is the invariant, any point which lies on the y-axis is the invariant point. So 0 comma 0 will remain as it is. So these are the two x-intercepts. So you can write that the two x-intercepts are, one is 0 comma 0 and the other one is 2.5 comma 0. As far as the y-intercept is concerned, whatever is this distance, you have to make it into half. So 2.5 half is 1.25. So half of 2.5 is what I have to mark here, which is 1.25. The y coordinate will remain the same, which is 6.25. Okay, so if I have to sketch this graph, I would sketch it this way. Okay, this is the first one. So y-intercept is 1.25 comma 6.25. Okay, moving on to the second one, y equals to 3 times f of x. Now I am going to do the working and drawing the graph with the blue color. Okay, we know it's a vertical stretch with stretch factor 3. Okay, and in x-axis is the invariant line. So if x-axis is the invariant line, any point which lies on the x-axis will remain invariant and will remain as it is. This point will remain as it is, this point will remain as it is. That means the graph has to pass through these 2 points plus this point. If the stretch factor is 3, if the distance from the x-axis is 2.5, it will be thrice the distance. 2.5 3 times is 7.5. So this point and the y coordinate will remain this, the x coordinate will remain the same. So 2.5 will remain the same, but 6.25 will be multiplied by 3. Okay, so I am writing down for the second part. This is for the first one. For the second part, x intercepts will be the same 0, 0 and say 5, 0, and the y intercept is going to be, the x coordinate will remain the same, which is 2.5, and the y coordinate will be 6.25 times 3. Okay, so the graph, if I have to draw it, 6.25 will be thrice this distance. Okay, 1, 2, thrice. Okay, assumingly if this is the distance, this is the point. Okay, so the graph is going to be like this. Okay. Okay, question number 19, if you can just focus your attention on this question. It says, state the transformation which maps the graph of y equals to x square plus 5 onto the graph of y equals to 3x square plus 5. If you notice in question number 19, the original graph is x square plus 5, and if you notice, it is being multiplied by 3. Both the terms are being multiplied by 3. That means 3 outside. That means it's actually a vertical stretch of 3 units of with stretch factor 3. So you will say it's stretch parallel to the y axis, or vertical stretch parallel to y axis with stretch factor 3. Question number 20. Figure 3 shows sketches of 3 graphs A, B and C. The equation of graph A is y equals to f of x. State the equation of graph B. Okay, if this is the original function, okay, the original graph, and you have to find out this graph, the equation of this graph. If you notice, whatever is distance, the distance from the y axis, it is being doubled on this side. Let's check this side also. The distance from the y axis, whatever it was like 2 units, it has become 4. That means vertical stretch of by the stretch factor 2. If you notice, the point x axis in this case is the invariant line, so any point which lies on the x axis is remaining as it is. So you can write that graph B is f of x multiplied by 2. Okay, so vertical stretch, we always write a constant here, which is the stretch factor. Graph C. If you look at graph C, the whole original graph has actually shifted this point has shifted here, so it has shifted 3 units onto the right. Okay, let's check for the rest of the points also. Every point has on the graph is actually shifted 3 units onto the right, so you will write if it is x minus 3. Okay, if it shifts onto the right, the sign will be negative. If it shifts on the left, the sign is going to be positive. Okay, if they ask you to describe this, you can also say that it's a translation by the vector negative 3, positive 3, 0. Question number 21. The point 4, negative 2 lies on the curve y equals to f of x. Find the coordinates of the image of P when the curve is transformed by y equals to f of 5x. It's a horizontal stretch, we know. Horizontal stretch with stretch factor 1/5. Okay. So we know that the point is 4, negative 2, which is 4 here, negative 2 here. This is the point, and you have to give it a horizontal stretch with stretch factor 1/5. Whatever is the distance from the y axis, right now the distance is 4 units. Okay, divided by 5, because the stretch factor is 1/5. So you have to make it into 1/5 of the distance. Okay, so 4 multiplied by 1/5, which is 4 times 1/5, which is 4/5, which is 0.8. That means this point is going to shift on to 0.8, negative 2. The y coordinate will remain the same, so 0.8, negative 2. Okay, So 0.8 comma negative 2 for the first part, and then I am just writing down the answer here, 0.8 comma negative 2. Okay, the second part they are saying, describe fully the single transformation which maps the curve y equals to sine of x onto the curve y equals to sine of x minus 90. Now, if you notice, it's a translation going on, and you have to shift the graph 90 degrees onto the right, 90 onto the right. Okay, so it's you can say it's a translation with translation vector 90 comma 0, because it's a negative sign, meaning it's shifting onto the right. Okay, question number 22. Figure 5.1 shows the graph of y equals to sine of x for values of x from 0 to 360, and two transformations of this graph. State the equation of each graph after it has been transformed. This is the graph of sine of x. If you notice that there is a vertical stretch of 2 units and the x axis being the invariant. So, the graph is going to be vertical stretch, meaning 2 times sine of x. If you notice this one, the whatever was the distance from the y axis, it has actually doubled. Okay, this distance was 180, this point the distance is 180, it has gone on to 360. That means it's a horizontal stretch of with stretch factor 2. So, how will you write it down? You will write this as y equals to sine of stretch factor is 2. So, you will write half x here inside the bracket. Okay, because whatever is the actual stretch factor, you reciprocate it and then write it down. Question number 23. The graph y equals to the curve y equals to f of x has a minimum point at 3 comma 5. 3 comma 5 is this point. Okay, this is the minimum point of the graph. Okay, state the coordinates of the corresponding minimum point on the graph of y equals to 3 times f of x. 3 times f of x, meaning this point is going to go up, and whatever is the distance from the y axis, from the x axis, the distance from the x axis is 5 units. Okay, it will go on to 15 units, then the x coordinate will remain the same. Okay, the next part, f of 2x, that means you have to give it a horizontal stretch of horizontal stretch with a stretch factor of half. Okay, so this point is going to go on to 1.5 comma 5. The y coordinate will remain the same, the distance from the y axis is 3 units, so now it's going to be 1.5 comma 5. Question number 24. It shows a sketch of the graph y equals to f of x. On separate diagrams, stretch the graph of the following, showing clearly the coordinates of the point corresponding to p, q and r. F of 2x, that means you have to give it a horizontal stretch of with stretch factor half. Okay, so you have to give the points negative, okay, 1 comma 2. So if it goes, if it becomes half the distance will be minus 0.5 comma 2. Okay, so I am writing it down, minus 0.5 comma 2. This distance, which is 4 comma 2, will go on to 2 comma 2, and this distance will remain as it is, because this point will remain as it is, because it lies on the invariant line y axis. In case of horizontal stretch, y axis is the invariant line. In this case, it's a vertical stretch of by 1 upon, the stretch factor is 1 upon 4. That means this point is going to come, it is 0 comma 4, it will come on to 0 comma 1 here. So, it's a vertical stretch with stretch factor 1 upon 4. So, 0 comma 4 will come on to 0 comma 1. This distance will be 1/4. Okay. So, it's 2. 2 divided by 4 is going to be 0.5. It will be negative 1 comma 0.5. Okay, and this point is also going to come on to 0.5. So, 4 comma negative 0.5, 4 comma 0.5. These are the 3 answers. Coming on to question number 25. Okay, on the graph, on the insert, draw the graph of y equals to f of x minus 2. The whole graph is going to shift 2 units onto the left, right, sorry. So, this point is going to come on to this point, this point is going to come on to this point, this point. Okay, so if I draw it, it will be somewhat like This is the graph. Okay, in the second part you have to give it a vertical stretch of 3, stretch factor 3. So whatever is the distance from the x axis, you have to make it thrice the distance. So it's going to come on to 6. The point which is on 1 is going to go on to 3. Okay, so the final graph is going to be somewhat like this. Okay. Moving on to the next question. Okay. Question number 26 and 27. These are the last two questions which are left. Okay. Figure 4 shows a sketch of graph of y equals to f of x. On separate diagrams, sketch the graph of the following, showing clearly the coordinates of the point corresponding to A, B and C. This is very similar to the previous one, so I am not doing this one. Let's do the last one. It says on the same sketch, sketch the graph of y equals to cos of x, y equals to cos of 2x for the values of x from 0 to 2x. Okay, y equals to cos of x, if I have to draw from 0 to 2 pi. Okay, cos of x, the graph is going to be this. This is the graph of y equals to cos of x. Okay, y equals to cos of 2x, that means a horizontal stretch with stretch factor 1 upon 2. That means every point is going to shift. Now, if I just draw it with some other color. Okay, so I have done the first part. Okay, the whole graph, it is a horizontal stretch of half. So there will be 2 rotations up till 2 pi. Describe the transformation which maps the graph of y equals to cos of x onto the graph of y equals to 3 cos of x. You will say it's a vertical stretch with stretch factor 3. So yeah, I can write vertical stretch, or vertical stretch can also be written as stretch or stretch parallel to the y axis with stretch factor 3. This brings us to the end of the video. Thank you so much for watching it.